So now let's move on to the intersection of straight lines. Okay, this is very simple also. So what you're supposed to do is you're supposed to equate the values of y, and then you have to find the value of x, and then you have to substitute the value of x that you get into any one of the equations, and you'll end up with the same y value. So yeah, so and then it's basically pretty simple. So let's just look at the worked example. So they have this one and this one. So they're going to substitute this, or what you can do is make y the subject of this and then equate y and y. Or you could just substitute this into this. Either way, you're going to get the same answer. So when they do this, they're going to get 4x plus 3 into 2x negative 5 equals to 15. Upon simplifying, they get 10x equals to 30. And then when they divide both sides by 10, they get 3. And then when you plug 3 into either one of these equations, you'll get the same answer, which is 1. So the lines will meet at 3, 1. This is very simple. And then they're doing the next question. So here they're making x the subject of the equation because it's pretty simple in this case. So when they plug the value of x into the equation, they get this. Upon simplifying, they get negative 11y equals negative 22. Essentially, y equals to 2. So when you plug y back into the equation, this equation, you get x equals to negative 1. So the two lines intersect at negative 1, 2. This is very easy. You just have to equate them together, or you have to substitute one of the equations into the other equation, and you have to find the value of one variable. And after you get that, you can plug the value of that into any one of the two equations in order to find the intersection point. So that's very simple. And now let's move on to the questions. So let's solve the first one. Also, I forgot to mention that there's another topic which is called as intersection of a straight line and a circle, which is basically the same thing. You're just supposed to substitute the value of y into the other equation. You're supposed to solve them. For a circle, you might get either one intersection point or two intersection points. So if it's two, then it's going to cut the circle at two distinct points. Or if it's just one, that means it's going to be a tangent to the circle. So it's the same principle, so I did not include the slide. But we will solve one question regarding a line and a circle. Okay, so now let's solve this question. So, yeah. Okay, first let's read the question. So a trapezium ABCD has vertices A, which is 3, 0, B, which is negative 2, 5, C, which is negative 4, 1, and D. So the side AD is parallel to BC. Parallel is the keyword. And the side CD is perpendicular to BC. So we find the area of the trapezium. So if AD are parallel, that means, okay, first let's just, draw the axis and let's just plot the points so it's much easier to understand the question. So 3, 0 would be somewhere here, and then let's plot B. So negative 2 approximately here, and then negative 5, let's say here. And then C is negative 4, so double of this. So here, let's say around here, and then 1 somewhere here. So, and then it says that A, okay, let's first write the coordinates. So this will be A, this is B, this is C. This is just a rough diagram. It's not very accurate. So B would probably be somewhere here. somewhere. So let's put it in red. So according to this question, the side AD is parallel to BC and CD is perpendicular to BC. Okay, so first let's find um, the gradient of BC. So let's do that. So we have the coordinates of B and C. So it's pretty simple. So it will be gradient of BC. Let's find it here. Gradient of BC. So if you've noticed that B is essentially the intersection point of CD and AD. So they have given us this information in order to find the equation of AD and BC in order to find D, which is the intersection. So yeah, that's what we're supposed to do. So let's do it. Gradient of BC, which is change in y by change in x, which would be 1 negative of -5 divided by -4 negative of -2. This would be 6 divided by, this is plus, so -2, which is -3. Therefore, gradient of CD is the negative reciprocal, so it's going to be plus 1 by 3. And now let's find the equation of CD. So let's do that. Okay, so we have the gradient of CD and we have the coordinate of C. So we can find the equation now. So it will be y minus 1 equal to 1 by 3 times x plus 4. It would be y equals to 1 divided by 3x plus 4 by 3 plus 1. We can simplify this to 1 by 3x plus 7 by 3. Let's call this equation number 1. Okay, and now we're supposed to find the equation of AD. So we've given that AD is parallel to BC. We found the gradient of BC, which is -3. So let's do that. Let's find the equation. Okay, so equation of AD. So we have the coordinate of A, which is 0, 3, 0, and gradient -3. So using this information, let's find the equation. So y equals to -3 into x minus 3. That will be -3x plus 9. This is our equation 2. So now let's equate them. Equate 1 and so on equating equation 1 and 2, on equating equation 1 and 2, we get -3x plus 9 equals to 1 divided by 3x plus 7 divided by 3. That's negative 9x plus 27, which equals to x plus 7. So 10x equals to 20 implies that x equals to 2. When x equals to 2, y equals to negative 3 into 2 plus 9, which is negative 6 plus 9. That's 3. Therefore, D will be 2 comma 3. So now we have this one, which is 2 comma 3. A is 3 comma 0. B is negative 2 comma negative 5. And C would be negative 4 comma 1. Now that we know the coordinates of the point D, let's find the area of the trapezium. Okay, let me erase all these because we don't really need it. Okay, now let's draw a more accurate version of the trapezium so we can calculate the area. Okay. So this would be a little longer, and this will form a right angle, and this would be B. Okay, so now we can find the area. So the area of a trapezium is the sum of the parallel sides divided by 2 into the height. So let's say this is E, this is F, and this is G. So the area would be E plus F divided by 2 into G. Let's first find E. E would be the square root of 3 minus 2, that's 1 squared plus 3 squared. And now F is the square root of, that's 2 squared plus 6 squared. Now let's find what this would be. So the square root of 1 plus 3 squared is the square root of 10 plus the square root of 2 squared plus 6 squared divided by 2. So that term would be 3, that would be 3 root 10 divided by 2. Now let's find G. So the value would be the square root of 2 minus of minus 4 would be 6. So 6 squared plus 3 minus 2, 3 minus 1, which is 2 squared. So the square root of 6 squared plus 2 squared is 2 root 10. Now we have to multiply this into this. So 3 root 10 divided by 2 into 2 root 10. This and this get cancelled, so that will be 3 into 10, which is 30 units squared. So that's our answer. So let's solve the next question. So we have this question. So the line x plus y equals to 7 meets the curve x squared plus y squared equals to 29 at A and B. and find the distance between AB. So first, let's do this. We're writing this in terms of y, making it the subject of the equation. Now let's plug this into the second equation. So let's simplify this. X squared plus 49 minus 14x plus x squared equals to 29. So 2x squared minus 14x plus 20 equals to 0. So x squared minus 7x plus 10 equals to 0. So this would be x squared minus 2x minus 5x plus 10 equals to 0. This would be x minus 2 into x minus 5 equals to 0. Therefore, x equals to 2 or x equals to 5. These are the two intersection points. And now let's find the value of y. So y equals to 7 minus x. So this would be 7 minus 2. This would be 5. So let's say A is 2 comma 5 and B would be 5 comma 2. So therefore the distance between them would be 3 squared plus 3 squared, that is square root of 9 plus 9. That's square root of 18. Let's see the answer. Yeah, square root of 18 units. So therefore we got it right.